Hello, everyone, and thank you for joining our webinar on how to contextually identify, prioritize, and prevent secrets in code. I'm your host today, Russ Miller, the VP of Marketing at Apiiro, and I'm joined by Roy Avrahamy, Application Security Engineer at Kaltura, and Igal Kreichman, our VP of Engineering. Throughout the day, if you have any questions, you can use the questions icon. It's in the upper right hand of your screen. It looks like a question mark, and we'll try to answer your questions as we go and also at the end. We're going to start with a presentation and then get into a panel discussion and handle Q&A. So the agenda today is pretty extensive. We're going to talk about many concepts about secrets from very high level to very low level. So we're going to talk to you about the business impact and also the technical details about discovering secrets in code and why it's so difficult. So with that, I will turn it over to Igal.
Hi, everyone. I'm Igal, and let's just jump right in. So first of all, let's try to understand when we say exposed secrets, what do we mean? And when we're looking at secrets, basically, we at Apiiro are looking at your source code. So we're trying to understand what is pushed into your source code, usually the Git repository. And there's a very large variety of files that we can find there that might include secrets. Those might be variables inside the source code itself, maybe something in your infrastructure's code templates. Sometimes a developer will just take some test environment or even a production environment and put it in a test code together with the access token that's needed to access it. And of course, lots and lots of instances when things are put into scripts or documentation where someone will just say, hey, you can access this environment using this secret. And then just pushes it into the source code. The most common use case is configuration files, where people will go as far as extracting the secrets into the configuration of the application, but then will take the same configuration and package it with the code and push it into Git as well. So why do so many people make this mistake, and how do we end up with so many secrets inside the source code? Usually it's just part of the process. It's part of the development. Someone starts a POC. He says, well, let's just write hard-coded line here to connect to the server, puts the secret in, and then, of course, as time passes, he just forgets to extract it, to handle it, and it just makes it into the code base. Another secret is another problem is usually just time. We need to plan a feature. We need to take into account it's going to take time to implement. And if someone is planning a feature but then doesn't think about the fact that there is no key management infrastructure in place in the same repository, he might overlook that and then find himself with a deadline he can't achieve, resulting in just secrets that get pushed inside the code without proper handling. So what kinds of secrets do we find inside all of those files? There's many types of secrets that are used for different purposes. We can start with user passwords that are just some text that's usually easy to remember by the user. This is used for user interfaces where someone will need to log in to some site, to some application, to some database, doesn't matter, and he will need to have something memorable that he can use. And the other side of that is usually the side that's connecting. If it gets, again, documented, tested, or even written in code, might get this password hard-coded inside this code, this source. Then we have APIs. APIs are basically programmatic interfaces that do not involve a human being between them. Those are usually longer, random generated tokens. No one is expected to memorize them in any way, and those will be passed in some textual form so that a user who generates that can easily copy them from one system to another so that the other side can consume or access information via this API. Another form is authentication tokens. When we say authentication tokens, we mean that there are lots of times, again, tests or scripts that want to bypass the user interface. So they might one time generate some token, some cookie, for example, using the password, but then store this token and keep using that without going through the entire authentication process every time. And again, we find lots and lots of those authentication tokens in scripts and automation code inside many projects. Another part is asymmetric encryption. Basically, whenever we need to sign something or have a good encryption, prove our identity to the other side, we will use asymmetric keys. And while the public part is, of course, less of a secret, the private key, however, is a very, very important thing to keep close and not have leaked. Otherwise, you might find yourself with cases of impersonation and severe data leakage. So let's try and look at some historic use cases where secrets were found and leveraged, not in the use case where we see lots of times in the internet that someone broke into some database and leaked the passwords, but rather specifically in this use case where the secrets are hard-coded into the code, which is what we want to focus on today. So a few years back, I was working for Symantec. We were building a endpoint protection for mobile devices product. And as part of that, we were writing code to protect your Android devices. When we started looking at mobile applications, what we found was really disturbing. So first of all, we found thousands of applications that were accessing AWS services and using keys. 20% of those actually used the keys in a way that was hard-coded. So they were not getting a key from the server, but actually the token was embedded inside the application. And with really low effort, any attacker could just go to the public Google Play Store, download the APK, decompile it, and look for strings where he would just find this key. So this was delivered all the way to the attacker's hands. What was even more disturbing in this use case was that not only did those keys give the attacker the option to use the intended functionality of the secret, but usually those secrets were not properly scoped in terms of permissions. And what we found was that using those keys that were used usually to upload some information from the endpoint device to the bucket of the company so that they can access the user's information led to other buckets that were accessible with the same keys. And we were amazed to find actual database backups with the entire client base of this the different applications that we were scanning. Another use case was quite a famous one. Back in 2016, an Uber employee accidentally pushed credentials of Uber's database to some public GitHub repository. That was, of course, discovered and resulted in a huge data leakage where those credentials were used to pull the entire client base of Uber, resulting in more than 57 million customers' information and over 500,000 drivers' information leaking out. Another research that was done by a big university basically scanned a lot of public repositories in GitHub. And what they found was that over 100,000 public repositories contained access tokens. And this is only access tokens. We're not talking about user passwords or anything else that lots of times included access to live services in the internet using those repositories. Now, while those examples are something live that actually happened in the past, I would like to also cover at least one example where you see a hypothetical example where a lot of customers don't deem Slack webhook as something that's secret. And this is an example where the implication is sometimes a bit hidden and looks harmless, but might be something much bigger, because something like a Slack webhook that only lets you post messages to a designated channel actually might lead to a phishing campaign where an attacker that obtains that with a token can impersonate something that's already trusted by the organization, a bot that they are used to getting links from, and replace that with some malicious site and start a phishing campaign that can be devastating to the organization that's experiencing that. So we need to make sure that we understand the actual impact of different secrets and what they can lead to when we prioritize our secrets. So let's talk a bit about a proper solution, but also, again, cycle back to the fact of why so many people make the mistake and do this hard-coded and find it hard to actually handle those secrets when they develop the features. So when we try to make a proper solution, we'll need to use usually a key management system. It can be any it can be any product from a range of products that handles that, but usually it's never without any friction. It always has some cost to implement, and what you'll usually see is that if the infrastructure is not in place, you will see many more secrets already embedded in the code, because the first step is always the hardest. If you don't have the infrastructure, people will make more mistakes because they just don't plan for that. And the first conclusion here is to implement the infrastructure as soon as possible and give people the tools they need to implement things fast and not waste time. The other thing is, let's say I already have the infrastructure, I still need to add my secret to the store. And in many cases, the access is really something that has many layers. Not everyone has the permissions. You need to open a ticket to someone in IT to add a secret to the key management system. And again, this just results in delays. A developer doesn't have time to wait for this, and he will often make the mistake of just temporarily putting the secret inside the code, but then never going back to replacing it. And also in terms of readability and simplicity of the code, I know it's not secure, but security takes an effort. You need to plan for that, and you need to understand that, yes, of course, the code that has the secret hard-coded inside will be much more readable, but it's just a mistake you can't make, and you'll need to implement the proper ways to integrate to this key management system, to pull secrets in a good manner and safely. Okay, so once we've covered why this happens so much and what types of secrets there are, let's cover a bit the ways that we and other products use to find secrets. So the first type of secrets is pattern-based. Basically, lots and lots of vendors do a great job of having this very structured, very familiar type of secret when they generate it, so that it's readable, you can copy it, and you can recognize it very easily. Basically, this usually is covered by a very simple regex. This regular expression will usually be very, very good in finding all of the instances. You almost never miss a token, and also will have very few false positives. This is something that's really considered easy today, and most very simple tools out there will make it a good work doing that. Then there are other vendors, or sometimes inside internal tools inside the companies, that do not have this structure. Basically, they use some secret key generator, random key generator, and they will just generate some random large number of bytes, and again encode them in some textual form that's easy to transfer and move around between systems. This is usually something that is more prone to false positives, because you could just the same way take some Unicode string, for example, a name of someone, and encode it in base 64. And once you do that, sometimes it just looks like a random key. Sometimes you will see some information that's hashed or is just compacted in some way, and it will look like a randomly generated long string, and it starts to get confusing. But still, we do have a lot of tools today to handle those. Usually we have hints where we can see the actual vendor who provides the key. Usually it will be inside the same code as the key, and we'll have some hint saying who's the vendor and where are we going to use the secret, as well as mathematical tools. Basically, if we leverage statistics, then we will find that a randomly generated string looks differently statistically than some English sentence or words, or even an encoded information, as long as it doesn't start with something that's really random. So again, using those tools, we can still detect those types of keys pretty well with a low chance of false positives. And this is something that, again, a lot of tools do well, and I think that we have really good results there. Which brings us to user passwords. Now, user passwords is a different domain a bit. This is free text. It has no statistical significance. It is not structured in any way. It can be anything a user invents that might be as simple as the word password or test or 1234, or some sentence that's very witty and encoded in with some characters and symbols, where a user might think that it's very secure and it will save him from brute force attacks. Still, we will see this in a very large variety. Those passwords might be passed as environment variables to different scripts. They might be used inside commands that access different sites directly, or they can be even embedded right into the code. In a recent research that SAP published, where they compared many vendors out there that are making that are trying to detect secrets, specifically around user passwords, they found the result to be over 95% of false positives, which just makes it impossible to use. Frankly, a security architect who's going to go over this rate of false positives is just going to give up and not going to make any effort to try and fish out the 1 in 20 results that is actually a real password. This is where we invested a lot of time, and eventually, after leveraging many tools, such as semantic code parsing, using actual natural language processing to actually understand the naming and conventions that the developer uses when he's writing the code, and as well as training models that actually helped us sift out all of those false positives, and we were able to go as low as 15 to 10% of false positives, which is something that we are really proud of here in Apiiro. And again, just to conclude this point, this is just a couple more examples where you can see why this is so confusing, and really, even a human being looking at a line of code without having the proper context, without opening the file, starting to read the code and starting to understand what actually happens in the logic, will have a really hard time to understand the difference between the left column here and the right, where on the left, those are actual real results and secrets used to access real systems, as opposed to the right side here, which is just a few examples of code that accesses some UI element and tries to either present some text on the screen or retrieve some field from some UI form from the customer, from the system's customer. Okay, so the last point here is just another way to understand that, okay, there's lots of secrets, okay, some of them are more easy to find, some of them are harder, but eventually also we need to understand that not all secrets are as easy to exploit or have the same business impact, okay? So those are just a few examples of things that we are looking at to try and prioritize and really point out the secrets that need to be addressed earlier than others, those that are urgent and those that are less urgent. And just a few examples to cover this. Again, this was already covered by the real world cases that we saw, but having the same secret published in a public repository versus a private one makes for an attacker the work very easy, because he can just go access GitHub and pull the secret instead of trying to somehow breaking into the organization and stealing the private repository. But while this might seem a bit trivial, you need to also understand that when you package the application, some of the code will be on the server side, and yes, it requires, again, for the attacker to gain access to the server. But on the other hand, there's a lot of code that gets packaged and sent to actual clients. And once it is sent to clients, it also becomes very similar to public, right? Because if we put this secret in some JavaScript code that's packaged and sent to the browser, or do the same with our Android application or iOS application that can be easily decompiled and we can look for strings inside, again, this just becomes public information that with little effort, an attacker can target and get this. And on the other hand, we also have the ease of exploitation, for example. Okay, so basically, once an attacker gained access and obtained those secrets, what can he do with them? So again, an AWS key that is a lot of times publicly accessible, a publicly accessible system on the internet that you just need the key for, it might have much more impact than when trying to access some internal database that will be much harder to get to. The same thing goes to buckets, right? So if I, by getting this key, I got access to an S3 bucket that might contain a lot of information that's very, very sensitive, it's much more critical to handle than if, for some reason, the default password of a newly created user in the system is leaked, and then for a given time until the user replaces the password, the attacker can gain access to a single user that has no information yet. So again, it's not that it doesn't have impact, it's just less important than other secrets.
Great. Well, thank you very much, Igal. We're going to start the panel discussion. And just a reminder that if you have any questions you want to ask any of us, you can use the question mark button in the top right. And what I really like about our couple of panelists here is that we have both the engineering side and the application security side. So we'll see if there are any differences of opinion or even disagreements. So for the first question, there's so much that as Igal has just presented about when it comes to identifying, remediating secrets in code. Roy, where do you start?
Well, that's a big question, actually. But I think the first step is, of course, visibility. So any tool that can detect secrets. I personally don't like so much the open source tools because it's really hard to manage, and it's like you need a lot of resources in order for it to be efficient. I like more the enterprise tools, of course, like Apiiro, that I can just quickly integrate our GitHub all our repositories in GitHub, and start continuously scanning for secrets. So I think this is the first step, the visibility. Maybe mapping the repositories into the right teams in order to later, when you have the secrets, who to blame for, and who should handle it and remove from the code. And after that, I think the next step is to have actually a proper framework for secrets. So you need to have some vault and some framework in order for all the code to switch from the secrets in code and to whatever solution you pick. After that, you start prioritizing and just prioritizing the most interesting secrets and the most dangerous one, I don't know, the internet-facing ones, etc., etc., and go to the appropriate teams and ask them to use the secret framework in order to remove the secrets, verify it with the tool you're using. I think this is the start for it.
If I may add something for that. So you mentioned the open source tools. A lot of those open source tools were not actually written for a crowd of security architects. Those, a lot of times, are actually written for attackers. And when you talk about tools that are written for attackers, they might be okay with a 99% of false positive rate, because as long as you got one that's real, you hit the jackpot, right? But for a security architect, you need much more correct results, but also context. The attacker doesn't care which developer did it, when did he do it, what was the context of the commit. Once you use a tool like ours, you actually get proper insight saying this secret was introduced by that developer on that date, and here's the commit, and you can see the entire code that he used when he entered this secret, and this gives you the start of the reference point to start handling those.
Yeah, and even the things like the automatic rules to be notified when a new secret was introduced to code, and who's the contributor that added it. Yeah, this is very, very beneficial things to have in a tool like that.
Great. So right at the beginning, Igal was going through the different types of secrets and the different places that you can find secrets. So Roy, what types of secrets do you find the most, and where do you find them?
So I think database connection strings, not too many, but this is something that we find from time to time, of course, in configuration files, unfortunately. Service accounts is something pretty popular in source code, and user credentials actually in scripts, not like actual not Java or C# files, but mostly DevOps scripts and stuff like that.
Good. So Igal, we'll go to you first on this one. So what are the hardest types of secrets to detect?
Okay, so yeah, I covered that a bit, but again, once we replace a human being with some code that runs and tries to automate this, we need to understand what's easy for a developer to write code to find. And again, everything that can be easily caught by its structure, that can be statistically significant, that I can write a mathematical model that scores that's easier, right? Having GitHub just changed a few months back their entire representation of the way they generate tokens. They are basically saying this is a huge problem to have GitHub tokens in your code. Let's help the developers find them. And then they changed the entire structure of the thing to be so easy. I mean, they had prefixes, they had CRC put into the token itself, so that after you have a candidate, you can go and revalidate that it's actually real. And then you also have APIs that you can later just try the token and see if it's still active or revoked. So all of this makes, first of all, a great vendor, but then also easy to find. However, once we stop looking at known vendors and move our focus to tools, to let's connect to a database, let's write a script, let's just have this piece of code here that is an integration test that actually connects to some environment to pull information. Here, conceptually, users, developers that write this just don't think of it as something that is that might have an impact in any way, and they just write some, it's a test code, it's something easy. Let's just put it quickly there. So the less structure that you have, again, passwords, the less thought that the person gives that, because it's test file, because it's documentation, we will see that anyway. The harder it is to find, from my experience.
Do you see the same, Roy?
Yeah, I totally agree. And actually, as Igal said in the presentation, user passwords are, I think, also hard to find because of the lack of construction and the high false positive of most of the tools. Yeah.
Got it. So one thing you mentioned earlier, Roy, was prioritization. So what secrets do you think of as more risky than others, and how do you prioritize those?
So there are several types. So I think again, as Igal mentioned in the presentation, AWS tokens for public services are, of course, can be very risky and pretty much easy to find, I guess. On the other hand, there are things that may be harder to use, like database connection strings, but if you do able to use them, it's like the impact is very, very big. So this is like, well, it's not easy to use, to achieve and use, but I don't want anyone to try to do it. So this is like, I think maybe the first ones for us to remove. The second one might be AWS tokens or any kind of service tokens. I think this is the most, yeah, I think those are the most risky ones in my opinion.
Igal, do you agree?
Definitely, and I think if we can elaborate here a bit regarding remediation, it's one thing to talk about remediation after the fact, but it's usually hard, right? I need to go find where this was used. I need to revoke it. I need to replace the production code. It takes time. I can't just go and revoke it because the code will break. And we need to make sure that it all starts with training. That it's not only the training for people to understand, hey, I need to use the proper infrastructure. It's also thinking in a secure way, in a security-oriented way. For example, for tools like AWS, they have the infrastructure in place so that even if something leaks, as long as you scope it down always to the minimal set of effect that you can, you will minimize the risk even before you start. Because if you have a separate token for your database backups and for your users' photo uploads, you already disconnected the two. So if this one leaks, the other one is not as horrible as it might have been if you were lazy.
Great. So, secrets and code are just one part of an application security program. Roy, how do you prioritize secrets compared to other types of security risks?
So I think the prioritization should start like, I'm interested in, of course, first of all, if it's a public or internal repository, I will, if it's a public repository, this is my first, like, I'm gonna look for secrets and remove them if there are. Fortunately, we don't have such, so it's good, but I do want to be notified if there are. Second thing, I think if the service is internet facing, because this is like, if there is some vulnerability in the service that somehow can leak our source code, this is, of course, we don't want it to happen. So the internet-facing services, and I think that prioritization is, as I said before, the impact. So like, I will remove first the database connection strings and AWS tokens, and the important services or public services. This is like the stuff we're going to look first and prioritize.
Great. So we have a question from the chat. So Igal, you had mentioned training developers. How do you train your developers about secrets and code? There's so much here, as we've seen in your presentation.
Yeah. So again, the way I see it, it should be split into two responsibilities. First of all, you need to have an owner for the infrastructure. You need to think of this before you start. This should be part of the planning. You need to have, again, security in mind. You need to explain to developers the implications, but also make it easy for them. And once you make it easy for them, they are less likely to make this mistake. So making them aware of that, also having the proper infrastructure, so understanding who's in charge of the infrastructure and embedding this so it's as easy as possible to leverage, and the developer doesn't have a lot to think about when he just needs to do something quickly. It's not a blocker for him. And then once you've talked about awareness and they are aware and they still do those mistakes, then you need to have proper tools that not only prevent them from doing that, but also have contextual training. So basically, you can have automation in place someday where you kind of say, hey, this developer tends to make this mistake, okay? So once he does, instead of having the entire organization, 1,000 people, have this 1 hour a year where everyone goes to slides and are falling asleep, you can do that very contextually. You can find those developers that make the mistakes and have the relevant slides or trainings sent to them so that they are aware that they did something that's not okay, and how do they do that in a correct and proper way in the future.
Roy, how do you do training?
So I think first of all, I think you can use security champions. You can shift left the knowledge to them, and then they will move it forward to their teammates. So this is a great way to use them. I think, like Igal said, I think there is need to be a culture of security, and this is not an easy task. This is like, especially if you're in a company that not a young company like that doesn't have much culture, security culture in it. So it's hard to change the current culture. But things like I don't know, send emails and newsletters, and have some um, lectures about it. Maybe bring someone to talk about stuff. About secrets, especially, and other security aspects. Um, and I think there can be like more active approach, like if there are new secrets introduced into code, so like automatically open Jira tickets and pull request to remove it. So they will learn with with they will learn from blocked pull requests and a lot of Jira tickets. That's also a way.
Great. So we have one final question from the chat. So with delivery pressures, is it ever acceptable to allow a secret in code and take that on as tech debt that you resolve as quickly as possible? Or do you take a hard line against that in every single situation?
Well, I think it depends really on the maturity of the company, because if there aren't enough, like if there is no secret framework right now, I can tell people don't add secrets to the code because there's no alternative to that. But if there is like a secret framework and there's a written policy for this should come from the higher management and like from the CEO, the CDO, from everyone, that there's no secrets in code. Once there is the management approval, I have no there's no secrets in code, and that's it. Like it's not me. It's it's the CEO. So like I don't know. I don't think there is. If there are the proper ways, like a secret framework, there's no there shouldn't be any excuse not to use it.
Good. You agree, Igal?
Generally, I do agree, but again, there's no right or wrong in this. If there is kind of, you have the impact of putting this secret in there, and there is a cost to delaying the launch, and this is going to cost possibly money for the company, and this is going to cause friction. So I think that, again, going back to my discussion from earlier, it's important to have the proper context. It's important to understand, to be able to do a threat model, for example, that's very, very easy, and you can understand, well, what will be the impact of that secret leaking? Okay, and how easy will it be for an attacker if he guesses or gets a hold of this secret? How easy will it be for him to actually take advantage of that, and what will be the results? Once you have that information easily in your hand, then it's easier to take a very hard decision of, I'm turning a blind eye on this in this case, or at least temporarily, to make my schedule. Okay, you shouldn't relax on security. You should always understand that if the risk is high enough, if the impact is high enough, you should stop. You shouldn't do that. But you should never say absolutely not on any case, because then it will generate a lot of friction and a lot of just bad vibes between the security organization and the developers that you don't want to cause.
Yeah, context is
We already have those frictions.
Great. So we have no more questions. So this was a great discussion. Thank you very much, Igal, for the presentation. And Roy, thank you for joining on the panel. And we appreciate everyone watching. Thank you.
Thanks.
Thank you very much.